Hello and good evening. First of all, I would like to express my deep gratitude for the kind invitation to the organizers. I've been very excited since I received the invitation last year. Initially, I thought it was for another Bernardo because the economists get an invitation to be here. But I was really excited to be able to join you. I actually was the only date marked in my agenda since last year. And so it's an immense privilege to be here. I was watching some of the lectures this morning, learned a lot, and look forward to interacting over the next few days with you. My name is Bernardo Strassburg. I'm an environmental scientist, and I've been researching on the interface of biodiversity conservation challenges and potential solutions for just over a decade. And I'll be talking to you today about an area I've been dedicating in the past 8 years, which is that of ecological restoration at scale. So just for a moment, I'll take you back to 2022 when the world agreed one of its most ambitious nature-related global target in history. In Montreal, the Convention on Biological Diversity 2022, the Global Biodiversity Framework, where if we manage to reach its goal, we are going to be the first generation to leave Earth in a better state than we found it. And that sink in for a second. But for over 10,000 years, we've been degrading nature. And if we manage to meet these goals, we're going to bend and reverse the curve to about the loss of habitats and end up in 2050 with more and higher integrity natural areas than we inherited. And as part of the Go Way, we have over 20 targets, and I'll be talking to you mostly about the second of these targets today, to restore at least 30% of degraded areas in the world. It is also, a couple of years before that, in 2020, the United Nations General Assembly dedicated the decade 2020 to 2030 as the UN decade on ecosystem restoration. It's important to note that myself and all the other experts involved, when we mean restoration, we also always make clear the importance that conservation is actually the first step. You should never take restoration as a substitute for conservation. This has always to be in addition to conserving everything we might be able to conserve. And the research I will share in the first part of the presentation centers around those three targets, which is, as if you recall, target number 1, it's about ensuring all areas are under participatory spatial planning. And that's quite important step to achieve all the other 20 goals. That's why it was eventually made it as the first of those targets. So talking about spatial planning in support of conservation and restoration policy, and then later practice. And this work was done, most of this work was done actually in support of the Global Biodiversity Framework as requested by the Secretariat of the Convention on Biological Diversity. The institute I founded in Rio, the International Institute for Sustainability, we developed a platform called Plangeia, where we use spatial optimization algorithms and knowledge from multiple different areas to ensure we will be able to meet the different goals under the constraints of land use. And that is important for a multitude of things, and underpinning all are the biodiversity data I will talk about in a second. Now, just one brief, that's the only methodological slide, I promise. For a while now, since the early 2000s, ecologists have been using an adaptation of the species area curve that, of course, you know much better than I do, posits that when we lose habitat, we lose species, not in a linear relation, but actually more in an exponential relation. So the first half of area that we lose about 10% of the species. But when we start going to the remaining half of the habitat, the extinction of species accelerate greatly. Some say this is an exponential curve, some say this is a sigmoid curve. It doesn't make a huge difference for the results I will show here. The most used relation is one with an exponent of 0.25 on this equation. So just to clarify, what we have, this works both ways, when you're losing area or when you're gaining area. So assuming the species original area covered those 8 squares on the left, and the species now has 1/8 of its original habitat, according to these calculations, it would have an extinction risk of 40%. If you are to recover those 3 other squares over there, you would reduce the extinction risk from 40 to 15%. That's at a species level, which is derived from a population dynamics. You can also aggregate that across all the species in the region of interest. And when you do that, the scary numbers start to appear. The first time I applied this for restoration was actually focused on a plant hotspot we have in Brazil, the Cerrado, our savannas in central Brazil. And there's a paper we published in Nature, Ecology and Evolution. It's actually my most cited paper. And it focused on the current moment, well, 80 years ago it was a current moment, of the Cerrado, and how, if we don't do anything, we would be about to witness a major extinction episode over the coming decades. So the areas in green, as you see in that graph, are the remaining, in the map, are the remaining areas of the Cerrado. Everything that is in white has been cleared, mostly for soybean. The areas in red are the projected deforestation in the Cerrado over the coming 30 years. If that happens, if we lose the areas in red, taking a species by species evaluation, plant by plant, species by species, and also a few vertebrates, but plant are 90% of the numbers here. This is what we're going to witness in the Cerrado biome in Brazil over the next 25 to 30 years. There's extinction lag after that, but those species would be committed to extinction. And the numbers are astonishing. I mean, one extinction is one extinction too much. But when you compare the number of recorded extinctions globally over the last 400 years with the current extinction depth in the Cerrado, and then if you project the business as usual deforestation scenario there, you arrive at numbers of colossal magnitude, and we are on track to this scenario. The 8 years since we developed these studies, the deforestation rate matches fairly similar the areas in red, and that's mostly due again to soybean expansion for international consumption. But part of the paper looks at the half-full glass, which is to say this scenario is entirely avoidable. And it's entirely avoidable without losing a single hectare of soybean production. The main reason for that is that most of the areas in white are actually very low productivity pasture lands. They have been converted, they're not native pastures, they have been converted using an African species, brachiaria, and it's currently occupied by low-level grazing. If we were to restore some of those areas, if we were to guide soybean expansion into those areas and not into the native remaining cerrado, which is one configuration that map shows, we would slash the extinction depth of the cerrado by 90%. And it's just one example of a species that would be 100% committed to extinction and would be saved in that scenario. Now, we then, this is a policy, so the research we develop always has a policy angle preferentially. So this became, we propose on the paper, is a framework for integrated policy for land use management in the region, taking into account the multiple elements needed to reach that sustainable scenario. And many of those policies presented here have actually been included in the new Cerrado protection plan from the new government. If they're going to be implemented, it's another story, but at least they're in the plan. Now, moving on to the more sophisticated approach we developed a few years later is to use optimization algorithms from optimization research and apply them individually to each species, to each benefit you want to maximize, to see first at the Atlantic forest scale, how can we go about spatial prioritizing land use planning. So not a generic land use planning, but one using science and mathematics behind it in order to meet the goals of different stakeholders, and in particular, to meet the goals of biodiversity conservation and climate change mitigation. For context, Brazil at that time had already agreed to substantial targets of ecological restoration. That's 12 million hectares, about twice the area of Portugal. And I co-developed that national plan, and we used that, this research we're going to show now as part of that. At the same time, this was before the UN decade, there was a global target of 350 million hectares, which is about the size of the EU globally in terms of restoration. So fairly sizable targets, and we've done about 1,000th of those targets so far. So we need to scale up and scale up fast. Now, I'll skip a bit of the methodology, happy to chat in the coming days about it. But before getting to the linear optimization algorithm, there's a crucial step of developing the benefits and costs we want to optimize for. And that's not a scientific question, that's a societal question. So we start talking to society, we begin the step, and we end up, but in the middle, the many scientific steps to turn data, species collection data from the field into the layers needed for those optimization algorithms. So I'll give just one example. In this paper for the Atlantic forest, we used about 3,000 species, and we used different ways to estimate their original extent, because unfortunately the Atlantic forest already lost 86% of its original cover. So where the species are today do not tell us the whole story. And if we're aiming to restore, we need to know where could we restore that species that would have a favorable habitat. We use climate and envelope niche modeling And we did that for woody plants, birds, and amphibians. Again, plants dominate the sample. There are about over 2,000 of the 3,000 species we use here. And what you're seeing in the maps here is already a per hectare estimate of how many extinctions we would avoid if we were to restore in that hectare. So in a sense, they are the priority areas to avoid extinctions of plants, birds, and amphibians. As you can see, birds and amphibians spatial patterns closely match. Plants are slightly different, but mostly they agree across the biome. And we use that to model multiple scenarios of how do we go about restoring 5 million hectares. That's 5%, roughly, of the Atlantic forest. Each of these dots is a scenario where we restore 5 million hectares. The restored area is identical in all of these scenarios. Now, oh, sorry, is there a way to, okay, good. So I'll start with this scenario here. Scenario number one is the scenario where we don't do any spatial prioritization, where we simply restore 5 million hectares across the biome, either in a random way or equally distributed over all the areas. If we do that, if we go about restoring a sizable area of 5 million hectares without spatial planning, it will be good. It will bring carbon sequestration. It will avoid extinctions. But that scenario has the triple distinction of being the worst possible scenario for carbon, for biodiversity. And it is number 50 here. So it is the most expensive scenario for society as well. So that's the scenario, what I call the business as usual. If we meet these targets, 12 million hectares, 20 million hectares, without spatial prioritization, we might waste the opportunity of a generation. If instead of that, we use science and we use the spatial patterns of species and of biomass and of economic costs that we know, we have a myriad of scenarios. For instance, this one here is not the best for biodiversity, it's not the best for carbon, but it's 90% of the best possible result for biodiversity. It's 80% of the best possible result for carbon, and it's one of the most feasible economically. And this scenario were only identified to the spatial optimization algorithm. It's not a scenario you would assume differently. Spatially, each of those dots is a map. So the biodiversity-only map is, these are the 5 million hectares you would restore if you're only thinking about biodiversity. Those are the 5 million hectares you would restore if you only think about carbon sequestration. Those are the ones you would restore if you only think about minimizing costs. We do have a bit of a problem here. And if you were to overlay maps, hoping for, we want all three, let's see the areas that match the priorities, well, we'd be in a bit of trouble. But that's where the linear programming come in, and we don't overlay the maps. We do a combination of them that has over 80% of each benefit, and that's that point I was showing in the previous graph. So this research then inspired, I presented it at a scientific conference, and the conventional biological diversity people were there, and they were drafting the new global biodiversity framework, and they asked kindly if we could reproduce that at a global scale. It took us 5 years to do the Atlantic forest one, using 3 different projects to support it. We had 6 months and no funds. The obvious answer was no, and of course we answered yes. And that's, I'll skip for a bit. This was the global analysis we did in support of the conventional biological diversity to understand pretty much the same things. I won't go about repeating the methodology. Now we have 22,000 species, And we have all biomes as well, which was an incredibly challenging thing. Before, there was only a biome per biome. This research was published in Nature in 2020, and the equivalent maps at the global scale. This is a map if you only think about biodiversity, where would be your top priority to restore. An important caveat I should mention at this conference: we don't have plants here. Sorry, don't boo me. There were no available data for plants at the scale needed. We repeated the exercise 2 years later with some of the plants, and we are in the process of repeating it with even better collection of plants now. The usual patterns are the same, with a higher importance, obviously, for plant endemism hotspots that gain higher priority when you include plants. But otherwise, the story remains very similar. And this is the equivalent graph, and that's what grabs their attention, that we could again restore 5% of the planet. If we don't optimize, we would save 40% of species from extinction. If we were to optimize, that number would be 11 times higher for the same effort. Again, a once-in-a-lifetime generation we should not miss. Based on those results, we organized in Rio for the CBD a workshop to draft the new target, and the overall conclusions were drawn from the concluding paragraph from the Nature paper, where we suggest that 30% restoration in optimal areas, they could mitigate 71% of the projected extinctions worldwide. At the same time, they would remove from the atmosphere half of all the carbon dioxide that has been increased in the atmosphere since the Industrial Revolution. That's the magnitude of the impact we're talking about here. And this means opportunities, and I'll get later on how this can become action and research. So again, that was what ended up being the new global target. And of course, myriads of trade-offs that's based on species extinctions. We then design a new modeling where we take into account pollination, coastal protection, ecosystem structural integrity, and many other ecoregion vulnerability and other aspects, also to study the trade-offs. Now, this is the one where we managed to include plants, and it's not yet the final version because we have a much larger collection now. And when I mentioned that, I would be discussing a bit of science, a bit of policy, and a bit of action, and how we use science to both support policy, and that was mostly at national and global level. And now sharing an experience that we've been developing over the past 2 years to actually put that science into growing back ecosystems in practice. So 2 years ago, I founded a bee company. A bee company is a normal company, a for-profit company, but that also needs to take into account the stakeholders, the surrounding communities, and planet Earth as a stakeholder in the final decision of its operations. And Regreen has a purpose to restore nature for life, and our mission is to deliver premium ecological restoration at scale, optimizing, using that science and others, for climate, biodiversity, and sustainable development, while generating returns for investors and major scientific advances. This is in the mission of the company, and this is some dialogue I would love to keep in the coming days. Our initial goal is to restore at least 1 million hectares of endangered tropical biomes in Brazil. To begin with, Brazil is already becoming Brazil and Colombia by the end of this year, and we don't aim to stop there. Importantly, all the projects implemented have to meet the 5-star ecological restoration standard of the Convention on Biological Diversity. So we're not talking about tree plantations, we're not talking about agroforestry systems. Those are very important. But what we do here is exclusively native ecosystem restoration, fully restoring the processes. The end point, in addition to composition, diversity, structure, the ecosystem processes must be restored for it to reach a 5-star ecological level. Investors are needed. The cost to do this is about $40 billion. But we developed what we believe is an attractive business case. So we already attracted substantial finance for the first projects through climate mitigation projects, biodiversity conservation projects, sustainable use of forest management. Just in a nutshell, this is how we use the science I showed you before to actually go about prioritizing restoration on the ground. Each of those polygons in the second figure are individual farms in Brazil. So we got the polygons for every single one of them. There are 5 million farms in Brazil. And we run those optimization algorithms to understand the impact for biodiversity conservation, for carbon sequestration, for each of them. And that guides the choice of where our incredible ecological restoration experts, you can see that that's Professor Ricardo Rodrigues from the University of Sao Paulo, is the leading ecological restoration expert in the tropics. An immense privilege to have learned everything I know of restoration from Ricardo. He's our chief restoration officer now, and he's the one telling us where to do. And that's complemented by an incredible team in Rios and other cities in Brazil. There's a tree nursery, I'll go back to that in a second. There's also a center for seeds and seedlings research. And then we supervise implementation plans by local partners. We don't aim to dominate the market. We are a platform in the middle, and then we have the local implementers following the prescriptions and implementing. And then we have a 4-pronged monitoring strategy, which is another exciting avenue for collaboration, where we mix traditional people-based, ground-based with eDNA sensors in drones, in planes, and in satellites, and especially the combination of those using AI to uncover new processes, and then we do a continuous implementation of adaptive management. Alongside the on-the-ground restoration, we consider that, well, it's not we consider, it's a fact. If the area was degraded in the first place, so this is not conservation, this is restoration. So by definition, the area was degraded in the first place. As a socio-ecological system, something happened, some pattern happened that led to degradation. It's not enough to put back nature there and do nothing else. If you don't change the dynamics of the socio-ecological system, you might end up in the same equilibrium point again. I mean, definitely not doing all this to see the forest degraded or deforested back again. And for that, the crucial element is understanding the socio-ecological dynamics and engaging with communities, sharing the benefits, doing it in a participatory way, co-planning what the restored forest would look like. It needs to be native. It needs to be 100% native. It needs to have all the ecosystem process restored, but it can have an interesting share of non-timber forest products for the communities to harvest sustainably, for instance, from some of the trees. So we take that into account and involve communities in other ways as well. There are different steps to monitor, and this is an exciting field, getting better all the time. When I started with this was bioacoustics, then quickly became ecoacoustics. Now we're looking to soil ecoacoustics as of last week, and you keep coming up with even more exciting things to do, and we really welcome collaborations I would just mention. The first place we started to operate, we chose where we could have the most impact for biodiversity. So, as William Lawrence once called the Atlantic forest the hottest of hotspots. This is very important. All hotspots are very important. It's not going to be a discussion of which hotspot is hotter here. They're all getting quite hot, actually. But the Atlantic forest, in terms of rare tree species, arguably the most diverse hectare of tree species was measured in this forest, this Wyatt Thomas from the New York Botanical Garden, and what would be the priority actions for the conservation of these endangered tree species and enriching and enlarging their population globally through replanting with seedlings grown locally and collected seeds is paramount. Tree diversity in this particular hotspot, so the area we chose, it's, you could say, the hottest hotspot inside the hotspot. Why is it a hotspot? A huge biodiversity diversity to begin with, unfortunately coupled with severe loss of habitat. And in the area in the southern Bahia that I just showed you, that process actually happened quite recently. So a bit further to the north, it started 520 years ago when Europeans first set foot in the land. But these areas here are entirely Brazilians doing, and it's quite recently. And the amount of, and the pace of deforestation is staggering. Basically, those most diverse tree hectares in the world are now consigned to 3 national parks in the last figure there. And connecting them in the context of climate change is a major priority. That's why we chose. From the paper, we also see it's on the top 5% of global priorities. On the Atlantic forest paper, it's in the 5% of the Atlantic forest priorities, and it's there in the very place. It's called the Discovery Coast. It's the UNESCO Natural Heritage Site. In the very place where Portuguese explorers first landed in the year 1500. And we are very proud to be working with this remnants of this indigenous community. They have a tree nursery that we set up with them, and they are providing the seedlings we are using to restore their original land. And after we restore, we're going to donate the land as an indigenous reserve to those communities. Now, we again at this more detailed level use spatial optimization frameworks. Here we use collected data for animals and plants, both endemics and threatened, to decide where to prioritize. And the exciting thing you can do when you're actually doing the local scale, you can simulate a project. And this is a 30,000 hectare project in that region that we simulate. And these are the extinction risks of species before the project. So there are actually 2 plant species here. And this is what happened with the post-project extinction risk for those plants. An interesting thing with plants is that we can be very proactive in the choice of the individuals we are planting. Animals will come back, and just saw an amazing, exciting talk this morning about the mutualisms and the relations between the seed dispersal animals and the plants coming back. And definitely natural regeneration is only possible through them. So we plant, but we also foster natural regeneration. We took into account current climate, but in that region, as unfortunately most of the world, it's also very important to take future climate change into account. So we're using, and we know there are loads of uncertainties involved here, but we're using the best available science as we can to project where to go. This is a simulation for the plant species. I won't go into Latin pronunciation in front of you here, but we're talking about the Massaranduba tree species, and that's the current viable area with current climate. That's what happens with a viable area for this species with future climate. And that's where we are focusing the efforts. I mentioned before, we have a fairly large tree nursery that we use to conduct R&D initiatives, so research and development about everything from seed collection to germination to growing seedlings adapted to future climates, and we welcome a lot of collaborations in that space. This is the first farm we started restoring just over a year ago, and it's quite exciting to see how fast in the tropics, in just under a year, we actually have shading already there, and this is going to progress quite fast. Now, in my last 5 minutes, I have 7, let's try to do it in 5. I would like to talk to you about the ambitions in terms of research that we have. The Green was founded by a scientist, and my colleagues joke it's a very complicated and expensive way of getting a very large field experiment. And they're right in a sense. The ambition is to turn those 1 million hectares into the largest integrated field experiment, because the restoration is already going to be paid for the projects. The monitoring is a demand of the market. So the monitoring is also already going to be covered. Now, all we need is bright ideas and researchers interested in researching together, whatever that means. The strategy that we developed is heavily based on collaboration, and it's open science, open collaboration in those areas. So there is an opportunity. The areas are degraded today. We can, of course, very meaningful research is done into conserved areas. But when you're designing the project from the start, thinking about science, choosing which species to use, what species will go next to each other, in which conditions, in which intensity, and you can monitor all that, you can probably answer new and exciting questions. And this large-scale network of research experiments, and we're going to do advanced field stations to host potential visiting fellow researchers. It's a very crucial part of what we're going to do. This is already, and some of these experiments are quite large, so this is already one with 1 hectare plots and different treatments. And again, we just started. So we are in the process of designing our research lines, our research programs, and prioritizing where to act, and figuring out with colleagues from multiple universities and research institutes on how best to work together. It's a huge ambition, but I also understand the interesting opportunity. The research agenda, the preliminary one, it's quite broad. So by the nature of it, we need to be better understanding aspects related to how forests will sequester and store carbon, how you can have sustainable production without harming the forest and without harming the 5-star ecological restoration process. Of course, production of seeds and seedlings, restoration models and techniques themselves, everything pertaining to restoration ecology, large-scale monitoring, integrated large-scale monitoring about many of the aspects we discussed here. My favorite column, the biodiversity and ecosystem services one, how restoration and biodiversity interact in both directions, how biodiversity makes restoration more resilient, and the same for ecosystem services. There's a whole column on socioeconomic. I mentioned before the importance of getting resilient also from a socioeconomic perspective, and a cross-cutting disruptive element of modeling AI applications into all this. And coming here, I was trying to think about what to perhaps propose to kickstart conversation about potential collaborations with researchers from all around the world in such important and core field for us. So I have some initial semi-random thoughts around a few topics, and with the permission of the organizers, basically I looked into all the topics you're discussing here, and I couldn't find a single one where we wouldn't be interested in collaborating through this experiment. So to conclude, we will leave open for those who would be willing to explore potential collaboration avenues, discuss what research could look like, what could we offer, what could be partnership opportunities. Just scan that code or go to the website at the bottom, or drop an email later on, or approach me on a coffee break. And I know it's been a long day, first day, and again, I'm very, very grateful for the invitation from the organizers and for your patience. Gracias.